Number 137 in your classic for transformations of sine and cosine, where you want to sketch one cycle of each function from A through G on some graph paper. So we have some already made graphs. We're going to go ahead and try to plot these. So for A, we're going to graph 2 cos x. So cos x, let's just get two graphs as baselines for cosine and sine. So for sine of x, we have that it starts at the origin, goes to a maximum, goes back to 0, and then gets a minimum at 3 pi over 2. This is 2 pi. This is pi, and then has a maximum at pi over 2. And then for cosine, so this is cosine of x, and this is x. We have at pi over 2, pi, 3 pi over 2, and 2 pi. Cos x starts at a maximum, goes down to 0, and then comes back to its maximum. So if we want to graph 2 times cos x, that's just our graph for cos x, but with an amplitude of 2. So if this is amplitude of 2, negative 2, then we go from here down to 2 pi, down to 0, or down to negative 2 at pi, back to 0 at 3 pi over 2, and then up to 2 at 2 pi. So that's one cycle. Now moving on to B, we have negative 2 sine 2x. So this sine 2x means that we're going to shrink our function, because if we plug in a value of, let's say, pi over 4 for x, this is the same as sine of pi over 2. So for our x's as pi over 4, that's going to be the same value as pi over 2. So if we were to give this a value, that'd be pi over 4, comma, then it's a negative 2. So actually, we plot it in the negative direction. So that would be pi over 4, comma, negative 2. Then we have pi over 2. Plugging that in for x gives us sine of pi. So we know that sine of pi is 0. So that'll come back to 0. And then sine of 3 pi, or plugging in 3 pi over 4 for x, we get sine of 3 pi over 2 times negative 2, which would be right here, coming back to 0. So in this case, our graph looks like this for one cycle. For C, we have negative 3 sine x over 2 plus 1. So we're going to start at our origin, but moving it up 1, we have a shift of 1. Then our scale factor is negative 3, so we're going to be going in the negative direction for sine. And then we have a vertical or horizontal stretch of 2. So this means that we're going to look something like this, where we have amplitude as negative 1, negative 2. So for our value, if we plug in x as pi, then we have sine pi over 2, which we know is 1 times negative 3, plus 1 will be negative 2. So we have sine of our function is going to be at pi negative 2. Then for 2 pi, we're going to end up at sine of 2 pi over 2, which is sine of pi, giving us 0, plus 1, giving us this value, 2 pi, comma 1. Then at 3 pi, we have sine of 3 pi over 2, which is a maximum negative 1. times negative 3, which is 3, plus 1, that'll be 4. So this is 1, 2, 3, 4. So 3 pi comma 4. And then for 4 pi coming back here. So this is how our graph looks for C. Okay, moving on to D, we have cos of x minus pi over 3. So this is our cosine function, just shift it to the right by pi over 3. So what we're going to do is say that our maximum, which was at the origin, now starts at pi over 3. And then our first 0 occurs here. Our minimum occurs at this value, pi plus pi over 3, negative 1. Then goes back to 0 at 3 pi over 2 plus pi over 3. And then back to our maximum at 2 pi plus pi over 3. So one cycle of this is our graph for that cycle. Now we have E. So E is just a normal sine, but shifted pi over 4 to the left. So we have pi over 4 to the left starting here. Now we know that our first maximum occurs at pi over 4 comma 1. Then we have another 0 at 3 pi over 4 comma 0. Then we have a maximum, or rather minimum, at 5 pi over 4 comma negative 1. And then a 0 again at 7 pi over 4. So this would be one cycle of sine of x plus pi over 4. Then we have our function for f. So f is 2. Our amplitude is 2. Then we have a shift of pi over 3. And we also have a scale of 2x. So this is a horizontal shrink of 2, but also a vertical scaling of 2. So starting off with cosine. So cosine we know starts off at 1, but since we're multiplying, we have an amplitude of 2. We're going to start at 2. Now we have a vertical shrink of 2. So this means that one cycle now is not going to occur over 2 pi, but it's going to occur over pi. So if we add pi over 3 to pi, this is where our cycle ends. And right in between, we know that we have a minimum at negative 2. So one cycle of this function would look something like this. And we can plug in more values to get a better approximation of it. But that'll suffice for now. Okay, moving on to G, we have y equals negative 4 times sine of 0.5x plus pi plus 1. So the easiest way to graph this is probably just to plug in values, make a table of values for different x's. So when we plug in a negative pi for x, we get a value of negative 3. At x equals 0, we get a value of 1. For x equals pi, we get a value of 5, and then 2 pi is back to 1. 3 pi is back to negative 3. So when we combine this now, we get a function that looks something like this over its one cycle.